So you guys, today is day 2 of our quadratic function review. We're just reviewing all the quadratic stuff we learned in grade 10. We've already learned how to graph a parabola and all of that stuff in the previous unit. Now we're getting down to some of the more technical stuff, like how to figure out the x-intercepts, the y-intercepts, the vertex, etc. This is part 2. So we started part 1 yesterday. We started to fill out this chart. We learned how to complete the square yesterday, and we started to fill out this chart. So we talked about how to figure out the y-intercept by letting x equal to 0. We talked about how to figure out the x-intercept by letting y equal to 0 and then factoring. We talked about the vertex, different ways to find the vertex. You can complete the square and figure it out that way. You can use the little trick where if you have two x-intercepts, you take an average, or if something's in vertex form, you just read it off. So we're going to continue from this point. Let's go ahead and for all 3 of the equations, figure out what the axis of symmetry is. Now for the axis of symmetry, you're basically, if you have a parabola that looks like this, here's the x-intercept, here's the other x-intercept, here is the vertex. The axis of symmetry is basically the line that splits the parabola into 2 and makes it symmetrical. So to figure this out, let's say the vertex here was 2, -6. Having the vertex is quite important, because all you need to do is you need to look at this number over here, and that tells you the equation for the axis of symmetry. Okay. Another way to figure it out is if something is in vertex form, like y is equal to 2x minus 2 squared plus 3, the axis of symmetry can be found just by looking at what's inside the bracket and solving for it. So it would be x is equal to 2 in this case, and for this question, it would also be x is equal to 2. Okay, so if you have the vertex, it's just the x value. If you have the equation, it's just whatever's inside the bracket. So given this information, let's try and calculate it for this. Here we have both. We have the equation here, and we have the vertex here. So both of those pieces of information tell us that our axis of symmetry is going to be x is equal to -4. For the, I feel like my screen is off. So you know what? I'm just going to move this over. There we go. For the second one, we just have the vertex. And so we just read off the x value, and it would be x is equal to 1. And then again, for the third one, we have the equation. So we're just going to look at this number over here inside the bracket. And that is going to tell us x is equal to 2 is the axis of symmetry. You may have to flip to the first page for this information, but when we're trying to figure out if it's a maximum or a minimum, you basically just determine if it opens up or down. If a parabola opens upwards like this, then you have a minimum. And if it opens down like this, then you have a maximum. Okay, so you have to basically just look at the sign of the first term. If it's positive, it opens up, it's a minimum. If it's negative, it opens down, it's a maximum. So based on that information from our other page, this is a minimum. And then the other 2 were both maximums. And then the next part is asking you, what is the value where something is a minimum or a maximum? I'll show you multiple ways to figure that out. Okay, so let's go back to our example here. I told you that our vertex here is at 2, -6. So I can clearly see in this example, we have a minimum, and it's going to occur at y is equal to, and to determine that, you just go to your vertex, you go to the side, and whatever number it hits on the y-axis, that is the value of your minimum or maximum. So on a graph, you can just read off whatever the y value is. From a vertex, you can figure it out just by looking at the y value of your vertex. And from an equation, you can figure it out just by looking at that number over there. So 3 different ways. From a graph, just read it off the y value. From the vertex, it's your y. And from an equation, it's just that last number. Okay, so here we would say we have a minimum at, and this is going to be at y is equal to -12, because if you take a look, I have a -12 here and I have a -12 there. For the second example, the y value of our vertex is 25, so it's going to be y is equal to 25. And then for this example here, our y value of our vertex is 18, so it's going to be y is equal to 18. Are we okay with this? Okay. Let's go ahead and now sketch the graphs of all of these. When you're sketching a graph, you don't have to be accurate in terms of step pattern or anything like that. The things you want to include are the x-intercepts, the y-intercept, and the vertex. So as long as you have those points, then you should be good for your sketch. Who starts? So I have my grids. I'm ready to start sketching. So let's take a look at all the important pieces of information for the first graph. If you turn to the first page, we figured out that our y-intercept was at 0, 36, and our two x-intercepts were at -6, 0 and -2, 0. So I'm going to place -2 here. I'm going to say -6 is there. And 0, 36 will be approximately there. Again, it's not to scale because it's just a sketch. I also determined that my vertex was at -4, -12. So -4, and let's say -12 is around here. That should be enough information for us to sketch this graph. So I have a point here, I have a point here, a point there, and a point there. Okay, so my two x-intercepts, my y-intercept, and my vertex. That should give me the general shape of the graph. And then you want to make sure you're labeling it with your the equation. So this will just be whatever the equation was at the top. I will write it in after so I don't have to scroll up. For the second graph, we had our two x-intercepts were at -4 and 6. So let's say -4 is here and 6 is approximately there. We had our vertex at 1, 25. And we had our y-intercept at 0, 24. So x-intercept, x-intercept, y-intercept, and vertex. So the general shape of the graph is going to look like this. Okay, and then for the last one, we have -1 and 5 were our x-intercepts. Our y-intercept was at 0, 10. Our vertex was at 1, sorry, was it 2? 2, 18. So that should be enough information for us to graph it. Okay, so here we have a point at -1, a point at 5. I think we said our y-intercept was 0, 10, and our vertex was at 2, 18. So this graph is going to look like this. Okay, and then don't forget to put all your equations in. Okay, now for question number 2, where I've given you two graphs and I'm asking you to write the equation of the following graphs, we're actually only going to do the graph on the left-hand side because that is our grade 10 review. The graph on the right, we are going to skip for now. We're actually going to learn more about this in tomorrow's class. But from my understanding in grade 10, the only equations of a graph you did, if you did them at all, was when the vertex was given. So let's skip the graph on the right. I'll remember to come back to it tomorrow. We're just going to do the graph on the left. So how exactly, besides guessing, do you figure out the equation of a parabola? The first thing you want to try to find is either the vertex or the x-intercepts. And in this question, you have both, but we're actually going to solve it using the vertex. So I recognize that the vertex of this graph is at 1, 2. There are, like I said, there are 2 ways to solve it, but we'll do the other one in tomorrow's class. And we need one other point that is on this parabola, anywhere on the parabola. So you obviously don't want to pick a point like here, because that one that I've drawn that's coming up, that's sort of in the middle, and that's not very accurate. You want to find a point that is exactly on the 2 lines. So you could pick either -1, 0 or 3, 0. Doesn't matter. You just need one of them. So let's stick with the positive number, just because why would we do negatives? Okay, so we have a vertex and we have a point. And this works for any parabola and any point. Sometimes the point doesn't have to be on the x-axis. It could be anywhere. It could be like 5, 6 or 8, 9. We begin with the general formula for a parabola, which is y is equal to a, because we don't know what the stretch or compression is, and we're not trying to guess. We want to be as accurate as possible. Now, we know if you have the vertex, this number, the number 1, is going to go inside of the bracket. And if the vertex is a positive 1, what am I going to write inside the bracket? Good. So I'm going to write x minus 1 squared. We also know the y value of your vertex goes on the outside of the equation, and it keeps its sign. So it's going to be plus 2. So this part is pretty straightforward. It's just putting in the vertex into the equation. What we now need to do is we need to actually solve for the letter a, because we don't know if it's going to be a half, it's going to be a third, if it's going to be 5/6. It could really be anything. We don't want to guess. We want to use algebra and try to figure it out. So that's where our point is going to come into play. See how we have a point over there? I'm going to call the x value and the y value of my point x and y, and I'm going to be substituting those into the equation and then solving for a. So my y value is 0. My a value is what I don't know, I'm trying to figure out. And my x value is a 3. Did anyone remember learning this in grade 10? Possibly, yes. Okay, good. Okay, so then we're going to just keep on going and solve it. So 3 take away 1 is 2. 2 squared is just a 4. I'll move, I'm actually going to move the 4a to this side, and I'm going to have a -2 here. I'm going to divide both sides by 4, and I'm going to get a is equal to -1/2. I did a little bit of funny math, see if it makes sense, because what I did is I moved the 2 over, it became -2, and then I flipped everything around because I want my a to be on the left-hand side, just the personal preference. And once we figured out our a value, we can now put it back into the equation, and we have figured out what the equation actually is. So I'm just going to move this over here, and we can go ahead and write down the equation is going to be y is equal to -1/2 bracket x minus 1 squared plus 2. Yeah. So question number 3 says, determine the equation of the quadratic function with the following characteristics. We have an axis of symmetry at x is equal to -2. We have a minimum value of -10, and we have a 0, which is an x-intercept at -3. Questions like these require a little bit of detective work, because you sort of have to put all the little pieces together and see what they're actually asking you. So I'm going to draw my grid, and I'm going to try and put in all the information that they told us. So they told us the axis of symmetry is at -2. And they told us that we have a minimum value at -10. Now remember, your axis of symmetry is the part of the parabola that is split into 2. So we're going to say this is x is equal to -2. And this information basically is telling me that I'm going to have my vertex down here at -2, -10. The question also tells me that I have an x-intercept at -3. And I'm not sure where my other x-intercept is, but we can actually figure it out. Your axis of symmetry is directly in between your two x-intercepts. So if your axis of symmetry is at -2 and one of your x-intercepts is at -3, for this question, where is your other x-intercept going to be? Yeah, and my graph is definitely not to scale, but maybe I can make it more to scale. Just put this a little closer. Good. So the shape of our graph is going to look something like this. We don't know where the y-intercept is, but that's okay. We don't really need to know it right now. You guys see how my graph is like swapping? There we go. We're trying to figure out the equation of this graph. Okay, so we begin with y is equal to the letter A. And I know my vertex is going to be at, I'll just write it on the side over here. Our vertex for sure is -2, -10. That's really important information. That tells me inside of the bracket, it's going to be x plus 2 squared. And outside of the bracket, it's going to be -10. Do I have another point on the graph? I do. I actually have two, but let's use the one that they gave us. So they told us that one of the zeros is -3, which means the point on the graph has to be -3, 0. We're also pretty sure the other point is -1, 0, but because they didn't tell us that, we'll use the one that they gave us. Now we're going to do the same thing that we did above. So we substitute in a 0 for your y. We don't know what the a is. And we put in -3 for the x. And then we solve. So I get my a value to be 10. So therefore, my equation is 10 bracket x plus 2 squared minus 10. Question? Oh, it doesn't matter. Unless it's like specifically asking for function notation, you can use either or. Yeah. All right. Let me tell you what you're going to do for the rest of the period. So I didn't give you a lot of homework yesterday, but you can see that I've given you a number of sheets today. This is handout A. Handout A is actually very much parabola review. So if you feel like you understand parabolas really well, you could sort of skim through this because we did do this in greater detail the last unit. Then we have part B, but part B is very important. I want you guys all to make sure everyone does part B because that's more of the stuff we were just doing right now. So question number 2 is asking you for the y-intercept. You're going to let x equal to 0. Question 3 is telling me you to state the vertex. So you have to decide how you're going to do that, the 3 different forms. Question 4, you're graphing each of them. And I didn't really provide you with grid paper, but if you have grid paper, you can graph it on that. If you wanted practice with standard form or completing the square, question 6 is super important because it says change from standard form to vertex form. So all of those questions involve completing the square. Obviously, you don't have to do from A to V. Maybe pick and choose a couple just till you get good at it. Question 7 is rewriting in standard form. And then question 9 is just more of the chart that we've been doing. Okay, so this is going to be, you guys have quite a bit of time right now, about 40 minutes, so you can get started on it now. And then this will also be for homework for the rest of the class, for tonight, I mean.